People are always debating, which is more important, solving problems or posing questions? Do we need individuals who can solve problems more, or those who can pose questions? From a micro-level perspective, solving problems is more critical as it sustains individual lives and stabilizes societal order. However, on the macro level of human civilization, posing questions is more crucial, also more challenging. From the ancient Egyptians' first observations of the moon to the 20th century proposition by the United States and the Soviet Union, can we land on the moon? Humanity spent a staggering 4,000 years. Yet, from President Kennedy's 1961 declaration we choose to go to the moon to the 1969 Apollo 11 mission's successful manned lunar landing, it took a mere 8 years. Hence, the saying goes, when the ape first looked up at the sky, humanity was not far from reaching there. Posing a question often requires accumulating material resources to a certain extent and elevating consciousness to a certain height, a very arduous process. Currently, humanity possesses the consciousness for interstellar exploration, indicating that the realization is not far off. So, what do we lack now? Undoubtedly, it's an efficient and massive source of energy, nuclear fusion. Welcome to Fantasiology, where bold imagination meets scientific logic. Now, let's imagine what human civilization looks like as we step into the era of nuclear fusion. After achieving nuclear fusion, humanity first established a space base on the moon. This decision was driven by the abundance of fusion fuels, deuterium and tritium, in the rocks and soil on the lunar surface. The moon's low-gravity environment, concentrated deuterium and tritium, and dry conditions provided a significant advantage over collecting deuterium and tritium from Earth's oceans. Consequently, humans deployed numerous mining robots on the moon, equipped with advanced sensors and mining tools to adapt to the uneven lunar terrain. A network of transport channels sprawled across the lunar surface, not only transporting ore but also facilitating the movement of robots. The collected raw materials could be used directly for nuclear fusion power generation, supplying energy to the robots. Besides nuclear fusion power, the moon lacks a thick atmosphere, making its solar energy abundant. Robots placed many solar panels on the lunar surface, serving as backup energy sources, resembling farmland from a distance. Humans treated the moon as a nuclear refueling station. Rockets were launched from Earth to the moon, where fuel was extracted from lunar soil to charge spaceships with nuclear fusion energy. These spacecrafts were then sent to more distant reaches of deep space or the next transfer station in the solar system, Mars. Compared to traditional chemical fuel propulsion systems, nuclear fusion propulsion systems offer tremendous energy density and high temperature, high pressure environments, resulting in significantly higher specific impulse for spacecraft. Previously taking 8 months to travel from the moon to Mars, it now took less than a month. This made considering Mars as a second transfer station possible. Humans established colonies on Mars in the temperate and water ice-rich polar regions, including residential areas, laboratories, industrial zones, agricultural areas, and a government zone hosting the United Nations. Abundant and affordable energy turned the journey to Mars from an exclusive and irreversible one-way ticket for the wealthy into a shared round-trip ticket for everyone. Traveling to Mars became as simple as touring and checking in at a destination on Earth. The Earth-Moon-Mars axis system in the solar system began to take shape. The extremely low fuel consumption of nuclear fusion enables the possibility of ultra-long-distance space exploration. Within Mars, the distances to Mercury, Venus, and Mars from Earth are all less than 1 astronomical unit, making human travel to these places relatively easy. However, beyond Mars, the distances to Jupiter, Saturn, Uranus, and Neptune from Earth are 4.20, 8.58, 18.22, and 29.05 astronomical unit, respectively. Before the era of nuclear fusion, reaching these places was virtually impossible. Using chemical fuel spacecraft would result in astronomical energy consumption. Even if the energy consumption is disregarded, the spacecraft cannot carry such a large amount of fuel, and the journey would take a lifetime to complete. In the nuclear fusion era, the time to reach these planets has been shortened by tenfold. As a result, humans launched numerous spacecraft to explore and unveil the mysteries of these planets. Ships loaded with nuclear fusion fuel easily reached these planets, and humans left their marks on all 8 planets in the solar system, a subterranean base on Mercury, floating airships on Venus, Jupiter, Saturn's moon Titan, and Uranus, as well as a deep-sea base on Neptune. Humans even reached the edge of the solar system, the Kuiper Belt, treating the asteroids, comets, and rocks there as individual outposts. Telescopes were set up, artificial satellites orbited around, and various laser detectors and soundwave detectors were deployed. The Kuiper Belt was transformed into the gateway of the solar system. Filled with curiosity and awe, humanity began to touch substances beyond the solar system, searching for the starlight of the Milky Way, other star systems on par with our solar system, such as the Alpha Centauri system, Barnard's star system, Luton 726-8 system, and Sirius system. These star systems might conceal information about the origin of the universe and potentially harbor other intelligent civilizations. Could our first contact with extraterrestrial races happen after exploring other star systems? The more distant future is beyond current imagination and speculation, something to be explored in future videos. Controlled nuclear fusion is indeed very challenging for humanity to achieve. However, if a technology carries the collective hopes of humanity, it is worthy of the concerted efforts of all mankind. If something is truly significant, no matter how challenging or daunting, we should courageously move forward. Always seeking light in the darkness, such is the tapestry of human history and the journey of every individual life. In the era of nuclear fusion, how will aspects of society such as education, law, institutions, and ideologies evolve? Stay tuned for Episode 4, Culture.